This video is on solving compound inequalities. All right, this first one is going to be what we call an AND inequality, where 4x plus 1 is between and including 5 and 13. All right, so what we want to do is we want to break this into two separate inequalities and solve each of those individually. All right, so first thing we want to do is kind of deal with these two pieces first. 5 is less than or equal to 4x plus 1. And we want to look at the second two pieces now. 4x plus 1 is less than or equal to 13. All right, and we're going to solve each of those individually. So let's start here with this one. We're going to subtract 1 from both sides. All right, so on the right side, the 1's cancel out, and I get 4 is less than or equal to 4x. All right, I want to divide both sides by 4. All right, so on the right side, the 4's cancel out. On the left side, 4 divided by 4 is positive 1. So we get 1 is less than or equal to x. Okay, you can also read that from the perspective of the x and say x is greater than or equal to 1. So x is going to be bigger than 1 or equal to 1 for this part. And now let's solve this one. We're going to subtract 1 from both sides again. On the left side, the 1's cancel out. Okay, so that's going to leave me with 4x less than or equal to 12. Okay, I want to divide each side by 4. Okay, on the left side, the 4's cancel out. Okay, and that's going to give me x is less than or equal to 3. Okay, so we've got two pieces here. We've got x is bigger than 1 and equal to 1 here. Over here, we've got x is smaller than 3 or equal to 3. So we're going to combine these two, just kind of like we had with the original inequality here, into one compound inequality where we can say x is between 1 and 3 inclusive. Okay, inclusive just means that it includes 1 and 3 as part of the solution set. Okay, so x is between 1 and 3 inclusive. A second inequality here, compound inequality, we've got what we call an OR inequality. Negative 8x plus 4 is less than 20, or 12x plus 31 is less than 55. Okay, they're already separated into two different inequalities, so we're just going to solve them as they are, and then we'll combine our solutions into one answer. Okay, so first thing we want to do is subtract 4 from both sides. The 4's are going to cancel out. Okay, and I'm going to be left with negative 8x on the left side, less than 16 on the right side. Okay, in order to get x by itself, I'm going to divide by a negative 8. Okay, on the left side, the negative 8's cancel out. Okay, on the right side, we're going to have 16 divided by negative 8. Okay, so because we divided by a negative, we're going to flip our inequality symbol. It's going to become greater than. So my solution for this part is going to be x is greater than negative 2. Okay, so that's the first part of my solution set. Let's solve the second part here. We're going to subtract 31 from both sides. The 31s will cancel out. Okay, that's going to give me 12x is less than 24. We want to divide both sides by 12. Okay, on the left side, the 12's cancel out. And that's going to leave me with x is less than 2. Okay, so this says x is bigger than negative 2. This says x is smaller than positive 2. So our answer is going to end up looking like the first problem, where we've got x is between two numbers. Okay, in this case, x is between negative 2 and positive 2. Doesn't include either of those values. Okay, that would be the endpoint on a number line, and we can do a video later on how to graph these on a number line. But this is the solution set for this compound inequality. And the final compound inequality for this video is going to look like this. We've got 3 minus x is greater than 5x, or 20 minus 3x is less than or equal to 17. Okay, this is an OR compound inequality just like the previous one, but our answer, our solution set, is going to be a little different. Also, in this first piece, we've got variables on both sides. Okay, there's a previous video you should have watched in how to solve inequalities with variables on both sides. Okay, so first step here is we want to add x to both sides because we want to get all the x's on the same side. It's easier just to go ahead and move those to the right side here. Okay, so on the left side, the x's cancel out, and it's going to leave me with 3 on the left greater than 6x on the right. Okay, we're going to get x by itself, so we want to divide by the 6. Okay, on the left side, I got 3 over 6, which is a fraction that can be simplified. That should be 1/2. okay, is greater than x. All right. We always want to think about it from the perspective of the x, so we're going to rearrange that and put x on the left side and say x is less than 1/2. Okay. The second part of the compound inequality, we're going to subtract 20 from both sides first. Okay. On the left side, those cancel out, and I'm left with negative 3x is less than or equal to negative 3. Okay, I want to divide both sides by negative 3. Okay. On the left side, the negative 3's cancel out. Okay. Notice we're dividing by negative, so the inequality symbol is going to flip. On the right side, negative 3 divided by negative 3 is positive 1. So the second part of my answer is x is greater than or equal to 1. Now in this case, we've got x smaller than, x is less than a number 1/2. And over here we've got x is greater than or equal to 1. So we're not going to have one of those between setups. X is not between two values now. We've got x going to the left of 1/2, not including 1/2. And we've got x going to the right of 1, including 1, okay? So my answer is going to look like this. It's a compound inequality. That's the videos for that. Hope that helps. See you soon.